Hello friends, welcome to my YouTube channel. My name is Prathamesh. Without wasting our time, let's begin. And if you please like, share and subscribe.
Operating modern enterprise AI at scale consumes vast amounts of capital, and right now, these costs are burning through corporate budgets. The frontier landscape is currently dominated by a few specific providers. Models like GPT and Claude have secured a near monopoly on high-level coding and complex reasoning tasks. But there is a bottleneck in this infrastructure: API inference costs. Calling high-performance models millions of times a day across an enterprise is often financially unsustainable. Last week, an anomaly launched that directly attacks this financial constraint. It is called DeepSeek V4. This diagram compares base operating costs. On the left are the high-cost thresholds for GPT and Claude. On the right, DeepSeek V4 operates at a 35 times smaller cost metric, while claiming benchmark parity with those American models. While enterprise developers receive that cost reduction via API, individual users can interact with the model directly on the app at no cost. Skeptical. When a tool is 35 times cheaper than the industry standard, a developer or CTO has to investigate exactly what is missing. We will evaluate these marketing claims by looking at the technical evidence. We will analyze this model across 3 specific parameters: economic efficiency, context architecture, and data sovereignty. This data triad determines if DeepSeek V4 belongs in a production engineering stack or remains a consumer-facing experiment. We start with the first parameter, evaluating the model's performance on standardized developer benchmarks. Historically, achieving high capability in logic reasoning and code generation required a high expenditure on compute. This scatter plot maps the market. The x-axis represents cost per token. The y-axis tracks benchmark performance. GPT and Claude plot high on both axes, expensive but highly capable. DeepSeek V4 reaches parity on the y-axis, but occupies a dramatically lower position on the x-axis. It hits top-level performance marks across coding, complex reasoning, and agent-based tasks. For developers, this means accessing a top-tier logic engine for a fraction of the traditional cost. However, there is a time-sensitive variable in the current API pricing structure. An active 75% developer discount pushes this data point even further left on our cost axis through May. This promotional pricing temporarily undercuts the competitive landscape of American AI providers. Engineering teams must determine how long this pricing model will remain sustainable before committing to long-term architectural planning. Purely on paper, the cost-to-performance ratio makes integration a logical choice for many teams. Yet, low cost is useless if the model cannot process complex enterprise data volumes. We have to examine the underlying architecture. This brings us to the second parameter, the context window. This is the model's short-term working memory. Most standard models hit their memory limits early. To solve this, engineers build latency-heavy retrieval-augmented generation, or RAG, pipelines to chunk and feed data into the model. DeepSeek V4 uses a 1 million token context window to bypass these limits. To visualize 1 million tokens, look at this capacity container. 100 separate PDFs and a complete unedited book fit into the memory space simultaneously. Practically, a user can upload all these distinct documents in a single prompt for analysis. This shifts the workflow. Developers bypass complex vector database lookups, extracting analysis directly from raw files. This allows for instantaneous cross-document synthesis, where the model compares all 100 PDFs simultaneously without losing data from the beginning of the prompt. Autonomous agents also benefit, as they can maintain long-running operational loops without losing track of their original instructions. Executing million-token prompts at this scale is economically viable here due to the 35x cost reduction. Despite the low costs and massive data capacity, enterprise adoption faces a significant physical barrier. The underlying infrastructure processing these massive payloads exists entirely outside of Western jurisdictions. Massive context and low costs create a powerful analytical engine, but its physical location dictates its legal and professional use. Cloud computing is still bound by physical reality, meaning every piece of data must travel through actual hardware and infrastructure across the globe. This introduces our third parameter, data sovereignty. This network topology map shows the physical architecture of DeepSeek V4. A data packet leaves a developer terminal, travels across the globe, and terminates at a server node located in China. This physical routing makes the model an unsuitable replacement for highly secure enterprise workflows. Proprietary internal source code, security credentials, and passwords must be kept out of this pipeline. Processing sensitive client data through this API carries immense risk and could violate strict compliance and privacy laws. DeepSeek V4 functions as a specialized engine restricted by these geographic data boundaries. We have a model that is 35 times cheaper with a massive context window, yet it remains disqualified for sensitive data. Most developers do not have to choose a single provider for every task. This diagram shows the enterprise solution, multi-model routing. An application router splits tasks down two distinct paths. Non-proprietary tasks like blogs and email scripts follow the safe path to DeepSeek for cost savings. Internal code and proprietary data follow the secure path to compliant models. Engineering teams that fail to integrate this split routing architecture are wasting capital on simple tasks. Teams ignoring these low-cost models for generic workflows are already 6 months behind the market's efficiency curve. Enterprise AI efficiency now depends on intelligently directing data flow based on its sensitivity and the cost of the compute. Scaling enterprise AI applications is currently hitting a hard ceiling. Development teams are finding that processing massive datasets through the frontier LLM pipelines of OpenAI and Anthropic requires a prohibitive amount of compute, creating token costs that quickly bottleneck deployment. Last week, DeepSeek V4 launched with benchmarks that target the performance thresholds of the industry's most advanced models, including Claude 3.5. This matrix illustrates the economic disruption. DeepSeek V4 achieves frontier-level capability at 35 times the cost efficiency of current market leaders. But this cheap compute comes with an operational anchor. It introduces immediate data sovereignty risks tied to geographic routing. On a purely technical level, the architecture is highly effective at complex reasoning, intricate coding tasks, and continuous multi-step agent workflows. Yet, engineering teams can't simply swap out existing OpenAI or Anthropic API keys for DeepSeek today. The security architecture required to handle the data flow is entirely different. DeepSeek V4 collapses the cost of high-volume inference, but extracting that value safely requires an uncompromising, heavily compartmentalized deployment strategy. To understand exactly how to integrate this, we need to analyze the specific cost differentials, map out the capabilities of its massive context window, and build a rigid data compliance framework. Surviving the next iteration of enterprise AI requires mastering the tension between maximizing extreme cost efficiency and enforcing absolute data security. To accurately assess the impact, we first have to look at standard unit economics. Traditional frontier models charge by the token, fractional pieces of words, meaning high-volume tasks scale your API invoice linearly and aggressively. This bar graph breaks down the quantitative difference in cost per 1,000 tokens. Migrating identical workloads from a standard GPT or Claude infrastructure to DeepSeek V4 results in a steep collapse in compute pricing. When costs drop exponentially, the return on investment math for previously impossible tasks suddenly clears. Running an AI review across an entire legacy codebase, which might have cost thousands of dollars yesterday, now costs a fraction of that amount. On the consumer side, the pricing is even more aggressive. For the individual user tier, access to the platform is currently completely free. This free tier acts as a textbook loss leader. By absorbing the compute costs up front, the company is prioritizing rapid market capture and user acquisition over immediate retail profitability. For enterprise developers relying on programmatic access, the API pricing structure remains incredibly low, functioning on a pay-as-you-go model that heavily undercuts standard market rates. Furthermore, they are running a temporary promotional window, offering an additional 75% discount on developer API access until the last week of May. Technical leads should be leveraging this specific discount window right now to sandbox and test internal deployments before that rate expires. This aggressive pricing structure turns massive AI inference from a premium, rationed resource into an abundant, deployable commodity. Economic theory only matters if the model can execute. The question is what engineering teams can actually build when token constraints are removed. The core technical mechanism enabling these new architectures is DeepSeek's 1 million token context window. This diagram shows exactly what 1 million tokens looks like in practice. It equates to simultaneously ingesting a full-length book, or up to 100 dense PDF documents in a single prompt execution. This scale allows development teams to bypass building complex pipelines. Instead of searching databases for small snippets of text, you just feed the entire dataset directly into the model for processing. Bypassing chunked RAG is highly effective for coding tasks. It allows the model to analyze entire software repositories at once, mapping out dependencies without losing contextual references across different files. It also provides the exact long-term memory required for autonomous agent workflows, allowing an AI to execute multi-step reasoning tasks over extended periods without forgetting its initial instructions. Crucially, independent benchmark performances confirm the model handles these massive ingestions reliably, avoiding the lost-in-the-middle recall issues that plague older high-context models. Achieving frontier-level reasoning on unchunked, massive datasets represents the primary architectural breakthrough for teams evaluating this deployment. But applying this compute in an enterprise environment hits an immediate, physical hard stop. This network topology map reveals the operational boundary. DeepSeek V4 processes all its API data through server clusters located in China. This geographic routing creates severe implications for international data sovereignty laws, triggering immediate conflicts with standard enterprise compliance requirements. To manage this, organizations must establish a rigid red zone boundary. Any sensitive client information or personally identifiable information is strictly forbidden from entering this pipeline. That red zone expands to include all proprietary internal codebases, API keys, and credential data. Under no circumstances should protected corporate assets be routed to these servers. Conversely, the green zone boundary covers safe enterprise use. This involves the high-volume processing of information that already exists in the public domain. Practical examples of safe ingestion include drafting generic email scripts, generating blog post copy, or summarizing non-sensitive research notes and public articles. While the compute itself is practically free, routing proprietary data through it is legally untenable. Strict data classification is the ultimate bottleneck to deployment. Integrating DeepSeek V4 requires treating it as a specialized, high-efficiency engine for specific subsets of an enterprise workload. This decision tree maps the mandatory bifurcated routing system. Prompts hit a conditional logic node. Restricted data routes down the yes path to compliant infrastructure, like Claude, prioritizing legality. Cleared data routes down the no path to DeepSeek V4, leveraging massive cost efficiency. Building and maintaining this automated data classification layer requires significant upfront engineering overhead to ensure it catches every edge case. But an automated routing layer is an absolute requirement. Relying on manual, individual choices made by developers copy-pasting code into a chat interface guarantees eventual data leaks. Organizations that fail to adapt will be paying massive premiums for basic compute. Competitors who successfully build these bifurcated pipelines are about to gain an insurmountable cost optimization advantage. The future of enterprise AI relies on dynamically routing your data to the right model, governed entirely by a strict matrix of cost, capability, and compliance.